You ever wonder how doctors can get a totally crystal clear picture of your brain or your knee or even your heart without ever making a single cut? Well, today we're taking a journey inside one of the most incredible technologies in all of modern medicine, magnetic resonance imaging. You probably know it as MRI. Let's dive right in.
I mean, it really sounds like something straight out of science fiction, doesn't it? How on earth can a giant magnet and some radio waves create these absolutely stunning, detailed images of what's inside of us? That's the big question we're going to unpack in this explainer, and believe me, it's a fascinating story of physics, biology, and some seriously clever engineering.
All right, so first things first, we need to get one really key difference straight. Unlike an X-ray or a CT scan, an MRI creates its picture without using any potentially harmful ionizing radiation. Not a single bit. It works on a completely different principle. So instead of, photographing your bones with X-rays, an MRI uses this incredibly powerful magnetic field and totally harmless radio waves to essentially listen to signals coming from inside your body. It is a fundamentally different and way safer method for seeing what's going on in there. Okay, so if it's not using radiation, what is it using? Well, the secret ingredient, the secret sauce, is something our bodies are absolutely full of: water. Yep, that's right, just plain old water. Our bodies are mostly water, and this simple fact is the key to everything in MRI. Because you see, every single water molecule, H2O, has hydrogen atoms in it, and these atoms have something very, very special inside them that the MRI machine can basically have a conversation with.
See, inside every single one of those hydrogen atoms is a proton. And for our purposes today, you can just think of every single one of these billions and billions of protons as a tiny microscopic compass needle. Now, normally, they're just all jumbled up, pointing in completely random directions. But that's all about to change. The moment you slide into that MRI machine, you're entering an incredibly strong magnetic field. And this field is so powerful that it makes almost all of those tiny little proton compasses in your body just snap to attention and align themselves in the exact same direction. It's kind of like a perfectly disciplined army, all facing north at once.
Okay, so we've got all our protons lined up. Now what? This right here is where the real magic happens. The machine is about to do something that will let it literally hear a story from your body's tissues. The whole thing really boils down to 4 basic steps. So after the main magnet aligns all the protons, the machine sends out a quick pulse of radio waves. Think of it like a quick tap that knocks all those compass needles sideways. Then the pulse stops, and as the protons snap back into alignment with the big magnet, they release a little burst of energy, a tiny echo. And a super powerful computer listens for all these echoes, figuring out exactly where they came from and what type of tissue they came from. This is exactly why MRIs are so incredibly detailed. Different tissues like fat, muscle, or fluid in your brain, they all tell a different story. Their protons realign at different speeds, which means they create their own unique echoes. The computer then translates this whole symphony of echoes into that final, beautiful, detailed image you see. But wait, it gets even more clever than that. Radiologists can actually fine-tune the radio wave pulses to listen for very specific stories. It's kind of like changing the lens on a camera to highlight different things in a photo. So, for instance, a doctor might use an anatomy lens, technically called a T1 weighted sequence, to get a really clear picture of an organ's structure. But if they think there's swelling or an injury, they'll switch over to a water lens, something like a flare sequence, which makes any fluid light up bright white. And with even more advanced lenses, like diffusion-weighted imaging, they can literally see the microscopic motion of water molecules, which is unbelievably powerful for spotting the very earliest signs of a stroke.
Now, we've been talking a lot about this powerful magnet, and that power is what makes MRI possible in the first place, but it also means that safety is the absolute #1 non-negotiable priority. Let's really get a sense of just how powerful we're talking about here.
Get this, 60,000 times the strength of the Earth's magnetic field. This is not your fridge magnet. It's a fundamental force of nature, harnessed in a hospital, and it demands an incredible amount of respect. This power is precisely why there are super strict rules you absolutely cannot break. Any ferromagnetic metal, we're talking things with iron or steel, can become a dangerous projectile literally flying across the room toward the magnet. That's why you have to take off all metal. It's also why it's absolutely critical to tell the staff about any implants you have, like pacemakers or even old surgical clips, so they can make sure they're MRI safe. And all those loud clanging and buzzing noises, That's just the sound of the machine working hard, switching magnetic fields on and off to pinpoint those echoes. It's a good sign. It means it's busy telling that story.
So when you put all of this together, the mind-bending physics, the incredible technology, and the strict safety, what you get is a tool that has just completely revolutionized how we practice medicine.
I mean, MRI's impact is just massive. For neurology, it's the gold standard for looking at the brain and spine. In orthopedics, it gives us this unbelievable view of a torn ligament in a knee or a damaged muscle in a shoulder. Oncologists use it to find and track tumors, and cardiologists can even get a movie of the heart beating in real time. The versatility is just astounding.
But when it comes right down to it, MRI's unique superpower is its ability to see soft tissue. While an X-ray is great for bones, MRI gives us this rich, detailed, and totally non-invasive window into the very things that make us move, think, and, well, live.
Think about it. From a random jumble of protons to a detailed map of the human brain, MRI is just an amazing testament to human ingenuity. It's a technology that makes the invisible visible, letting us diagnose and understand disease in ways we could only dream of before. And it really makes you wonder, as this technology gets even more powerful, what other secrets hidden deep inside our bodies will it help us uncover next?